Hey there, I've got your daily GRE problem. So this one's pretty common. In fact, I think it's probably popped up on most of the standardized tests that I've ever taken, where you have to do something about the diagonals of cubes. Take a second to read it over and recall that this is one of those GRE problems where choice A is that column A is bigger, choice B is that column B is bigger, choice C is that the two are equal, and choice D is that there's not enough information for you to tell. So pause the video here and attempt to answer this question. Okay, I'm going to assume that you gave it a shot. I'm going to walk you through it really quickly. One of the reasons why this problem is great is because it touches on this concept of special right triangles and also the Pythagorean theorem. So let me show you. So you're looking at this, this length of diagonal AB. Really, that's what you need because you need to compare it to this, this value √3. So that's this diagonal here. If I can draw it in there, okay. And in order to get that, you're going to have to look at a couple different triangles. Notice that the diagonal of this base right here, it forms a triangle with the sides. And then I'll throw this in here. This is a side length. But that base forms a triangle with these two sides as well. Okay? So I'm going to now flatten these triangles out so you can see them. So we've got the triangle with the two sides and the blue line. And then we've got the triangle that has the other side and the blue line as a base and the red diagonal that we really want. Okay, so hopefully the color coding helps you see where these triangles go to, right? So like this one goes down there, and this one is that triangle there. Okay, so we have to solve the green and the blue triangle first before we can solve the green, blue, red triangle and get ultimately the length of the diagonal that we're ultimately interested in. So this is because these two sides are the same length because it's a cube. That makes this a 45, 45, 90 triangle, which is what we call a special right triangle. There's two kinds of special right triangles, 45, 45, 90, and 30, 60, 90. That's a thing you should study for the GRE. I'm going to put some links for you to help study those on Khan Academy, but I'm going to put those Khan links in the description so that you can make sure you're studied up on those. You do not want to go into any standardized test without knowing special right triangles. It's just like a perfect thing, low-hanging fruit. It makes a long problem a short problem. Anyways, for special right triangles, if this is a 45, 45, 90, then that means that the ratio of the side lengths, I like to use the variable u, are u √2, which in this case, since the side length is just 1, it's just 1, 1, and 1 √2, or in other words, √2. So this blue line we just figured out was √2. And remember, the green line is the side length, so that's 1. So now you can use the Pythagorean theorem, because this is another right triangle. You can use the Pythagorean theorem, which is, you don't recall, that c squared equals a squared plus b squared, where c squared was the hypotenuse. And so that means that our red line squared, I'll go ahead and keep calling it c for now. C is going to be equal to the square root of these other two sides squared. One of those is √2 squared, and the other one would be 1 squared. And √2 squared is 2, and 1 squared is 1. So as it turns out, the length of our diagonal is exactly √3, which means the correct choice for this one would be choice C, that the two sides, the two columns, are equal. Okay, so like I said, I'm going to throw some links down in the description. I'll go ahead and throw Pythagorean theorem down there just in case you need a refresher. But the main one that I would like you to study before you go on to the GRE is special right triangles. You should be lightning fast at any special right triangle problem. It's definitely going to come up multiple times on any GRE for sure. Okay, see you tomorrow. Bye.